Don't have many slides, so it's going to go quick. I'm Burçin Becerikgörber. I'm an associate professor in the University of Southern California in the Civil and Environmental Engineering department. So just to give you an idea, because the presentation and the research you're going to see is slightly different than I believe the other presentations you have seen thus far. My group focuses on responsive and adaptive built environments. So we don't focus on infrastructure, but we focus on humans. And in the specific case, in the next two presentations, is going to be occupants of buildings. So we focus on learning from and responding to user behavior. And behavior, we define it as patterns, activities, preferences. And we try to mathematically model this behavior. And as part of this modeling, we use it for prediction of what's going to happen in the building. And it could be, for example, occupancy, how the occupancy patterns change in a building, or in identification of component failure. And we translate this information to impact both the building behavior and the user behavior. So with that in mind, and I call this cybersocial physical systems, or human in the loop CPS. It's not just me who's talking about these. But the idea is bringing humans into the decision making. One of the things that we're very interested in, this is one of my students' research, is how humans make decisions. So human decision-making is defined as cognitive process of choosing the preferred options or courses of actions from the available alternatives on the basis of certain information and consideration. So in this context, we're talking about energy efficiency, and this presentation is about thermal comfort. So something happens, and then we process that information and we respond, and in the context of thermal comfort, we change something in the environment. We interact with a building element. For example. So there's so many external factors that impact human-building interactions. So for example, building properties, and again, coming back to the thermal comfort, if your building is oriented towards south, north, or how it's been constructed, or physical environment, sunny sky or rainy sky, or temporal factors, for example, different seasons, winter versus summer. These are external factors, but they're also internal factors, right? So how humans and buildings interact is also being determined by physiological, social, psychological, and social factors. So in this particular research, my students is interested in understanding human decision-making, and there are different models that have been used to understand human decision-making. So they're descriptive models that describe actually what one actually does. Normative prescriptive models describe one can or should be doing. Naturalistic models describe what one should do. And perception models describe one does or chooses from options based on sensory information, and that's what we're interested in. And the reason is long, but basically descriptive models do not take into consideration decision makers' experience. Normative prescriptive models focus on how actually decision makers make decisions. They don't really focus on how decision makers make decisions. And naturalistic models doesn't provide micro-level information. However, perceptual models enables embodying human behavior through their responses to multisensory stimuli. So again, this presentation or the whole research is kind of a side line of a bigger research, and that's why I'm trying to explain all of this. So when these internal and external factors come together, and when there's discomfort, we interact with our buildings. So we focus on, in this particular research, thermal comfort and HVAC systems, because these systems consume about 43% of energy consumption in the US, and they affect thermal comfort and indoor air quality. And if you're not comfortable or comfortable, let's say, in a building, then it affects also human health and well-being, performance, and satisfaction. So thermal comfort, not all of you might be familiar with this research, is defined as state of mind, representing one's satisfaction with the thermal environment, and is usually measured by subjective votes. And thermoception is the sense by which animals perceive the temperature of the environment and their body. So there are different studies that's been done in literature, in thermal comfort literature, and these studies usually either take place in a real building, and these are some of the examples that you see on the left, or in climate chambers. However, in real buildings, and that's preferred location because you're working with real buildings and real people, it's hard to test different behavioral scenarios and collect thermal behavior data, and there's lack of control. And what I mean by that is, if you look at these pictures, it depends on like where your office is. If you're in an open space plan, if you're by the window, if you're in actually an office without a window, it happens in the US, unfortunately. And climate chambers provide that lack of control, so you can maintain, for example, the temperature of the chamber, but they don't provide the mundane realism, right? So they basically look like this picture on the right. That's from NREL. And it's time-consuming, it's not very efficient. You really have to spend the resources to basically buy one of these chambers, assemble these chambers, and maintain these chambers. So what we were interested in, and that's where, long story short, can we use immersive virtual environments because they perceptually envelope users, and they could provide experimental realism and experimental control. Basically, you can put these people in any kind of environment and control the physical world. So you can systematically test different influential factors, and they can facilitate collection of occupant behavioral data, which could be used in building performance simulations. And they could be also combined with chamber studies. Basically, if we can use immersive environments, you can put the goggles and put the person in a chamber, control the environment, and then provide the realism. So this is what we were interested in this paper: are virtual environments adequate representations of physical environments? So we looked at the literature. There are several studies looking into thermal stimuli in the virtual environments context. We haven't found anything related to thermal comfort, but there's like a virtual hell. So you can have a trip through flames, for example, and they tested how people perceive the temperature. There are head-mounted wind devices. There's wind and warmth feelings measured in the virtual reality. And there is a scaled wind tunnel for atmospheric display and such. But again, we were interested in this using immersive virtual environments in a very specific context. So what we have done is we have taken our lab and we have virtually modeled it. And I'm going to show you some of the pictures of it. So you see our lab, I mean one of the students' lab. The top pictures are the physical office, and the bottom pictures are the virtual offices. So we ran the experiment with 19 participants. That's what the conference paper is about, but I'm going to present you a larger scale because we kept running the experiment after the pilot. So far, the results are from 56 participants. So we measured different variables. We measured the perceived temperature, perceived thermal comfort, satisfaction, type and number of interactions, and the people's presence in the immersive environment. So this is what the experimental design looks like. So we had two groups, hot group or the cold group. If you were in the hot group, you were put in a 28 Celsius degrees room. And if you were in the cold, you were put in an 18 Celsius degrees room. And where you started physical or virtual, we alternated. And we gave them two generic tasks, and we asked them, obviously they're going to be uncomfortable in these temperatures, to set the environment to their satisfaction, to basically release the stress, right? So this is what the sessions look like. The ones on the left are from the virtual session. The person basically sat in the same environment but put the goggles and looked at a virtual screen and read the passage and basically did some comprehension questions. in the physical session, this was all done in the physical environment. And these were the types of interactions. So they could adjust local heater or cooler, either in the physical environment or in the virtual environment. They could drink cold and hot beverage, again, in both environments, adjust the desk fan, adjust thermostat, adjust radiant heater, adjust clothing level. It's not in the picture, okay? So that's what the experiment was about. And then we basically compared people's perception of temperature, satisfaction, comfort, interactions, number of and type of interactions in both environments. So I didn't bring all of the statistical results, but basically there was no statistical difference in terms of people's perception of temperature. So we asked people to guess the temperature in the virtual world and in the physical world. So in both cases, they weren't able to quantify the perceived temperature, and this is in line with literature. Actually, we're not good perceptors of the temperature, not exact at least. And prior to interactions, percentage of participants feeling lower than it actually is, was higher than it is. And as soon as they interacted, if they were in the hot environment, they thought it's lower than it is, and if they were in the cold environment, it's higher than it is. I know this is a mouthful and not easy to understand, but basically, as soon as they interacted, doesn't matter which environment they're in, they felt like the condition is much better than it actually was. So we also looked at comfort and satisfaction, and we looked at the delta before their interactions with one of those 6 remedies and after their interactions. And very similarly, in both physical and virtual environments, as well as in both cold and hot conditions, comfort and satisfaction significantly increased after the participant interacted with the remedies. And there was no statistical difference between the 2 environments in terms of the deltas of comfort and satisfaction. They were similar, also deltas, in both virtual and physical environments. And we thought that we could use thermal comfort and satisfaction assessment methods as markers of thermoception. And I'm not getting into the details, but we used the ASHRAE 7 scale satisfaction and comfort assessment. So we also looked at the number of interactions. So this was one area that actually differed a little bit. Number of interactions are marginally similar, were marginally similar in physical and virtual environments. We didn't see any difference in the hot conditions, but this marginal effect was coming from the cold conditions. And we have done multiple surveys looking at presence, personality, and other things. And what we realized is in the virtual cold environment, people lack the presence, feeling of presence. And this is very important in virtual environments. You really have to have the presence feeling. And so there were significant positive correlations between one of the presence tests and comfort under hot conditions, but that didn't exist in the virtual environment. So maybe one lesson is you really have to make sure that the presence is high in the virtual environments if you want to use these tools for this kind of reasons. And these are the type of interactions, and we looked at the first type of interactions, and there wasn't any significant difference in either of the hot and the cold conditions. Here you can see the hotter colors are for the hot environments, and the colder colors are for the cold environments. So the first interaction was most of the or majority of the first interactions was adjusting the local heater and the cooler. And then the second interaction was drinking beverage. And then things differed a little bit in terms of what they have done in terms of first interactions, but no statistical difference again. So in sum, we concluded that there's no, at least with the data we have so far with 56 participants, there's no significant difference. Perceived comfort and satisfaction, type of initial interaction, and number of interactions, however, there's a bracket there in hot conditions, could be used as the markers of thermoception. And I talked about the marginal insignificance significance in terms of the cold virtual. So what's next? So, I mean, we have done all of this because we are thinking about using virtual environments to understand people's decision making, not only for thermal comfort, but also visual comfort and other kinds of performance criteria. So this is one of the few benchmarking studies we're conducting. We want to understand the reasons behind human-building interactions, the triggers, frequencies, and patterns. And we want to model these. The idea here is if we can mathematically model these, and it's not a trivial job, of course, and understand the relationships between different interactions and their impact on different performance criteria, we could design buildings differently, right? Or we can operate buildings differently, or we can have more interactive spaces like a kinetic facade, maybe following users' preferences and such. So that's again a little bit of the bigger idea. So I'm not sure how I'm doing with timing, but I think that's all I want to present.